This is Algebra 2 at Trig, Unit 9.5. We're talking about probabilities of independent events. Events that don't affect each other. So two events are independent. If the occurrence of one has no effect on the occurrence of the other. Kind of like flipping a coin. Probability of getting heads after flipping it once does not affect the probability of the second one. For instance, oh, here it is, I guess. That's funny. If a coin is tossed twice, the outcome of the first toss, the heads or the tails, has no effect on the second one. That's what we just said. But if you draw a card out of a deck and you keep the card out, the probability changes. You now only have 51 cards. But these are independent. So the probability of independent events, and you got to read the story problem to see if the event is independent of each other. The probability of A is going to be multiplied by the probability of B. In general, the probability that n individual or independent events occurs is the product. It doesn't matter if there's 2 or 3 or 4 storylines. You would multiply them together. So here we have a school fundraiser. We're going to sell 150 tickets. To a mall gift certificate, or 200 raffle tickets for a booklet of movie passes. You're going to buy 5 raffle tickets for each of the prizes. So you actually have bought 10. You're going to buy 5 for each of the prizes, so that's 10. So what's the probability of A and B? You want to win the A, so that's the that's the mall gift certificate, and B is the movie passes. We're going to do this because the probability of winning the mall certificate does not affect the movie passes. Doesn't change your probability. So the probability of A is going to be multiplied to the probability of B. So you have 5 tickets for the 150 tickets available for the mall, and you have 5 tickets for the 200 available for the movies. So that's going to be 25, 5 times 5. And 2 times 15 is 30 with 000 after it. So that's 30,000. So there's our probability. It's not very big. Very small chance that you're going to win both raffles. So we multiplied our probability of the one with the probability of the other. So just to explain this a little bit, the same idea would be true for true and false. If it's 50% chance to guess the correct answer on a true and false question, what's the probability of guessing 2 questions in a row? If you have 2 questions that you have to guess at, multiple choice, or not just multiple choice, but true and false, it's 1 out of 2 chances you get it right, times 1 out of 2 chances. You have a 1 out of 4 chance, 0.25, of guessing 2 true and false questions correctly. A spinner is divided into 10 equal regions. So we're going to give ourselves a visual of a spinner. So since there's an even amount, there's 10, we're going to cut it right down the center. So there's 1, 2, 3, 4, and 5. 5 slots. Now I can extend that line all the way through, and extend that line all the way through, all the way through. And we get 6, 7, 8. Oh, what did I do wrong there? I drew in an extra line. There, 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 there. Okay, so that's 9. And I'm sorry, this is 10. Poof. All right, there's my 10. What is the probability that 3 consecutive spins, where we're going to spin it 3 times, will result in a perfect square? All 3 times will be a perfect square. So what numbers can we land on would be considered a perfect square? 2 times 2 is 4. So 4 is considered a perfect square. 3 times 3 is 9. So 9 is considered a perfect square. And also 1 times 1 that's a perfect square. So those are the 3 spots that we want to land on. So we're looking at the probability of 3 spins, all perfect squares. What's that going to be? What do we need to do? What's the first spin? 3 out of 10 for the first spin. There are 3 happy, favorable spots out of the 10 available, possible spots. So you've done the first spin. 30% chance of landing on it. What's the probability of getting it the second time? You still have 3 out of 10. We don't lose a spot. It's okay if you land on the same spot again. So it's not going down. It's 3 out of 10. That's what makes this independent. Probabilities don't change. So notice that for you to land, this is 30% chance of landing on it the first time, but for you to land it on it back to back, that would be 9 out of 100. That would only be 9% chance for you to spin it and land it twice. There's a 30% chance you'll land on it once, but there's only a 9% chance you'll land on it back to back. It's just an interesting way that the 30% and the 30% work. And then there's 3 out of 10 for you to land on it the third time. So that's 27 over 1,000. That's 0.027 that you will land on it all 3 times in 3 consecutive spins. And really, it didn't matter what the numbers were, as long as there were 3 spots. There's nothing magical about the 4, 9, and 1. But that fit our storyline. So notice that we multiplied them together. They're independent, meaning that the probabilities do not change as you move through. Now, this one is a whole nother case. First, you need to understand what the question is. During each of the 5 days of Secretary Week, a secretary is randomly given a prize. There are 10 possible prizes. Maybe you won a stapler, maybe you won a piece of tape, maybe you won a pencil, or maybe you won a $500 gift card. Okay? What's the probability that the secretary receives a $500 gift card at least once? That means you might win it once. You might win it twice. You might win it 3, 4, you won it all 5 days of the week. Because it's available. The same prize is available each day. So you might win the same prize twice. You're going to have a lot of hole punches. You're going to win a hole puncher 3, 4, 5 different times. Who knows? We're hoping to win the super prize, the $500 grand prize. So we have different ways we can do this. Option number 1. This is probably the most logical way. Definitely not the easiest way. But this is what it's asking. It's saying that you're going to win the one super prize out of the 10, and you're going to win that one time. That means that there are 9 prizes out of the 10 possible. And how many times during the week are we going to win those? If we won the grand prize once, how many times are we not winning the grand prize? 4 times, because there's 5 days during the week. This probability, if you take a look at it, is really 0.1 to the first power times 0.9 to the fourth power. That is a 0.065. That's the probability that you're going to win the grand prize anytime once during the week. But that's assuming that you only played once. That is the probability for any one day. But how many times are you going to play? You're going to play 5 times. So we have to multiply this by 5.
So we already counted the 5, like the 1 and the 4.
These are 5 different days. So this calculation was the probability of you winning it on, essentially on Monday. But because you didn't win it on Monday, does that mean you never won it? That means you're going to do it again. And again, and again, and again. You're going to play that game 5 times. So the probability of winning it once and playing the game 5 times has gone up. You have a 32% chance if you get to play the game 5 different times. Or you have the grand prize and you're going to win it twice. That means you don't win the grand prize how many times? 3 times. You're playing 5 days. 2 days you win the grand prize. 3 days you don't.
Well, you make it 2 though.
Because you win it twice.
The question's asking something different.
So, what I want to point out here, how can we win twice? You could win on Monday, you could win on Tuesday. You could win on Monday, you could win on Wednesday. You could win on Monday, you could win on Thursday. You could win on Monday. You could win on Friday. You won twice. Or you won Tuesday and Wednesday. You won Tuesday, Thursday, Tuesday, Friday, Wednesday, Thursday, Wednesday, Friday, or Thursday and Friday you won. How many ways is that possible? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 ways that you can win 2 times. How can we calculate how we could do that? How do we get the number 10 here? Well, Mr. Weber, you just showed us how we did 10. 5, choose 2. That is the number 10. 5, choose 1. That is the number 5. So this calculation is 5C1. This calculation is 5C2. So if you're trying to figure out the number of ways that you can win the prize twice, you don't have to draw them out to calculate it. You can actually do 5C2. That helps a bit. Okay? So now we're going to consider winning the prize 3 times. And not winning the prize how many times? 2 times. If you won it 3 times and you don't win it 2 times, that's actually just like this. You didn't win it on Monday, Tuesday, Monday, Wednesday, Monday, Thursday, Monday, Friday. You didn't win it 10 times, which is the same as 5C3. You can try that in your calculator. 5C3 is the same thing as 5C2. Or you could win the grand prize 4 times and not win it once. That's going to be 5C4, which is the value of 5. Or you can win the grand prize all 5 times. That means you did not win the grand prize. Or, I'm sorry, you win the grand prize 5 times. That means you didn't win it 0 times. And 5C5, you won it all 5 times. There's only one way you can win it all 5 ways. You won it every day. So that's a crazy calculation. So if you go to your calculator and you say 5 times 0.1 times 0.9 to the 4th plus 10 times 0.1 squared times 0.9 to the 3rd plus 10 times 0.1 to the 3rd power times 0.9 to the 2nd power plus 5.1 to times 0.1 to the 4th power. That means you didn't win it 1 time, plus you win it all 5 times. Excellent. Let's see where my little mistakey was. Okay, I guess they're saying it was right there. I don't remember putting that in there. Do you? Okay. This is winning it all 5 times. There it is. So that is 0.40951. We could round that to 0.41 if you want. So that's a crazy way. Do you understand? Could you explain what this means? Can you discuss that? Okay, the other option, and you're going to like this. Option number 2 is to take 1 minus the probability of not winning $500. Well, that would be 1 minus 5C0. What do you suspect 5C0 is? If you don't choose any of the items, if you don't have any winning day, how many ways can you not have a winning week? There's only one way that you cannot have a winning one at all. You just didn't win any of the days during the week. That means you have 1 out of 10 that you did not win, and the 9 out of 10 prizes you won every time. All 5 days. So we'll go to our calculator and say 1 minus 1 times 0.1 to the 0 power, we don't even have to say that, times 0.9 to the 5th power, because we did it all 5 times. And that came out to be the exact same. So either way you want to do it, this way makes a lot of sense. It's a lot more calculations, more spots to get confused. This is the subtraction method that we've used in several different problems. And you see that we can actually get the same exact answer. So when you start to think about story problems in your head and what's the probability of this or that, a lot of times you have to worry about these 5C2 situations that go along with every calculation. That complicates it. They're not always so simple and clean. We don't have combinations with this because there's just 3 out of 10, 3 out of 10, 3 out of 10, and we multiply them together. This was the or question. We were going to win it once, twice, 3 times, 4 times, or 5 times.